Adaptability is key. All right, so let me start off with PA2. So PA2 is graded, and people did a really good job with it. Yes?
What day did you say was the midterm?
He says it's the 15th.
It's next Wednesday.
Yeah. It's whatever Canvas says. Okay. So he's a reliable source. Yay. Yeah, so midterm the 15th. So we'll talk sometime beforehand about the midterm, but you know, it's the same as every of these CS classes. It'll be some programming, it might be some short answer. I posted 2 more quizzes, which are due a week from today at 8 in the morning. They're like 5 questions. They should not take you more than a few minutes, but if you don't know the answers, write some code and figure them out. So some short answer, some programming on the midterm. We'll pin down specifics next week. So PA2 looked really good. It was obviously a fairly complex problem. It had lots of moving parts that had to work together. But mostly people had the right framework. Sometimes all the details didn't get worked out, but by and large, the majority of people had a linked list of linked lists, which was the goal. So that was good. I'm going to go through some sample code and make some comments along the way. There were lots of ways to do this assignment. There was a particular way that I had described in the assignment and in talking in class, which a lot of people, probably the majority of people, did not follow, which is okay. But in some cases, people took a harder path, and in a lot of those cases, they didn't end up being completely successful. And usually when I suggest a way to do something, it's going to try to make things easier or more logical or tie them into what else we're talking about. But that's just one of many ways to do most of the things in here. What other general comments? So you had to build your tar file correctly. A few people are still not building the tar files correctly. Some of these people are also not coming to class, so that may be why they're not getting the message. But most of the tar files looked exactly right. Commenting your code, so you were not supposed to submit a main.java. Some people did. I didn't take off for that. Some people only put their name inside main.java. And I didn't take off for that because that's still part of what you submitted. But ideally, you know, you're making a class called index utility, and for someone to use that, they need the word class and location list class and so on and so forth. Those are the things that you would, for example, publish if you were making this available to other people. That's definitely where you want your name, right? And a description of what the code does and things like that. So let's be honest about commenting, right? The level of commenting I'm asking you for is much more than what I do myself when I write code. Okay, every single method I write, I don't begin with a comment block. I don't describe each of the inputs and outputs. Okay, that's practice. That's something that you may be expected to do for an employer, for example. But I absolutely put comments on my code while I'm writing it because, and maybe it's just me, to me this helps me with my coding. I equals I plus 1, I know I'm incrementing I, but why am I incrementing I here? Well, if it's absolutely, positively clear to me 100 years from now, I can wake up from a sleep and I'm going to know exactly why I'm incrementing I there, I might not put a comment on it. But in general, as code gets more complex, as algorithms get more involved, I want to remind myself why I'm doing things because I'm writing the code, I'm creating it, and I need to understand what's already there to be able to keep writing and adding, and possibly to go back someday and modify. So commenting the code itself, right, is something that most programmers I know do while they're writing the code as part of the process, as opposed to writing the code and then going back and adding comments just because you're supposed to have comments. Header block, with your name and the date, you don't need that to write the code, so that often gets glommed on at the end. So I sympathize if you don't like putting comments on every field that you define and so on, but we're practicing. The other thing I wanted to mention was I've been asking people to stick to the command line for PA1, PA2. Use your favorite editor, compile with Javac, run with Java. A good chunk of the class has not been doing that. They've been working in Eclipse or some other IDE to do their development. I didn't take off points for that. Okay, it's pretty clear in most cases when that's been happening because you can tell by the way the code is styled or the comments and so on. But just, be aware that if I ask you to write a main method on an exam and you can't write public static void main parentheses uppercase string variable name bracket bracket close paren etc., right? I'm assuming you can do those things. Not because I want you to memorize them, because you should have been doing them for the past 4 weeks inside an editor. So if you've been using an IDE that's writing some of that code for you, or writing try-catch blocks or whatever, just make sure that you are able to do that without the IDE for exams and such. And also, for interviews and things like that down the road. It's pretty common now, interviewing for programming positions, to be asked to write some code, right? Usually on a whiteboard. It's like, go up here and show me how you would, implement a doubly linked list in Java. And that's pretty standard. PSU, to get into their computer science programming, you sit in a room and write code. And you got an editor and that's it, and no web. And it's part of their admission process. So it's becoming more common, so the practice you get here and the better you get at doing that, the more it's going to help you down the road. So, questions before we go through some code? And then we can talk about PA3 if you want.
I have a quick question.
Yeah.
So after I finished my PA3, I downloaded it on my machine, and then I was practicing importing and exporting.
Okay.
And then when I imported it to Eclipse, there was this, under my index utility, it had this one error it's not really an error, but it's like a warning that says like resource leak. And I was wondering what that meant. So is that where I start my scanner variable?
Probably means you didn't close your scanner if you're using a scanner.
Mm-hmm.
So resource leak is saying that you've opened a file or you've done something like that without closing it out.
Okay.
And it'll get closed out when you exit.
Okay.
It's not like it's going to degrade your computer or something, but it's just letting you know that you did this, you should do that.
Okay.
Did everybody sign in? Oh, yeah. Thanks. There you go. All right, so the cleanest way to do this would be 5 classes. Okay, index utility, word list, location list, those were required classes. But I also said in the assignment you probably want to make separate classes for the nodes of your list. So a few things about this. If you make a class called index utility, okay, first of all, class name should be uppercase. Okay, that's a convention. It doesn't matter to the compiler. It's a convention pretty much everybody follows. And in the cases where somebody's code wouldn't run or would throw an exception right away or would loop forever, I generally went inside and tried to see if there was a quick fix so that I could, more accurately grade what was going on. In the cases where class names had uppercase letters, this was significantly faster than in cases where class names started with a lowercase, right? Sounds silly, but you get used to making this association. You see an uppercase and it's a class, you see a lowercase and it's an object. And it's a convention that most places and most people follow. So try to get in the habit. Class names begin with an uppercase. Objects, instances of classes, fields, etc. generally begin with lowercase. Sometimes static fields are done in all uppercase. that's not as common. But class names. All right, so the next thing, if you have a class named index utility, it should go in a file called indexutility.java with the same spelling as a class name. This does not always matter, but if you explicitly declare the class to be public, the compiler will force you to put it in a file of that same name. Well, it won't force you, but it will refuse to compile if it's in a different file name. So that's the second thing, match the file name to the class name. The third thing is you can declare what's called an inner class. You can be defining a class called word list, and inside there you can have another statement which says class word list node and defines the word list node inside that word list. And there's nothing wrong with doing that, but again, I think it's cleanest to put every class in its own file, right? Because now if you want to edit a word list node, is it inside wordlistnode.java, or is it inside wordlist.java, or is it inside indexutility.java, right? And again, this is a consideration for me if I'm trying to sort of tweak your code to get it to run. The easier it is for me to do that, the more likely I am to be successful, because I'm not going to spend an hour trying to fix someone's code. But if I can get in there and pretty quickly see what's going on, and it's like, oh, you forgot one semicolon, then everything's perfect, right? So so just things to think about. These become less of an issue now that we're working in an IDE, because you create a new class, it goes into a new file, and so on. But just things to be aware of. All right, so I went with 5 classes. Index utility is the main interface that the user has to all of this stuff, right? They create a new index utility that gives them access to the build index method, which returns a word list, which gives them access to a print method, which shows them the index. So all of it kind of comes down from index utility. And then word list is the word list node is the nodes in it, location list is an integer, linked list and location list node is just a node in that. So here's the next general comment. Technically, you can make a location list whose nodes are also location lists. And some people did this, and it works, but it's not really proper. So here's a location list. And it contains a few things. It has an add to end method for adding to the end of the list. Maybe it has a print method for printing out the linked list, or maybe it has a toString method for taking the entire list of numbers and turning it into a string. And it's got something that points you to the first node in the list. So that's usually what a location list looks like. But you could go ahead and add a piece of data and a field called next that points to another location list. And you could build your linked list out of these things. And so I could have a 5, and I could point to here, and I could have a 10, and point to here, and I could have a 12, and a null. And bingo, I don't need a location list node. But the nodes in my linked list are more than just an integer and a pointer to another node, right? Each node has an add to end method, and a print method, and a toString method, and a field called head that points to, I believe, this first node in here. And it's just kind of tangled up, right? It works. If you do this correctly, you can make this work just fine. But it's logically kind of intertwining two things, right? The nodes and the list itself of nodes. And it's going to be heavier processing, because every time that I create a node, I'm actually creating a much larger object. And it's going to be harder to debug, probably. And, you know, you could take this to an extreme. You could just have one class for your entire program, just called big, right? And big could contain a word list, which could be comprised of, you know, bigs, and big could have a word and a pointer to another big and a pointer to another big that we use to hold integers. And it could just be one big class, and you just have a big long linked list of this one type of object. But that's like seriously making things complex, right? This partitioning of things into objects based on the reason why this object exists is part of the whole kind of mindset of object-oriented programming. So if you want a node that has an integer and a pointer to a node, make an object that has an integer and a pointer to that kind of object. And then use that inside whatever you're putting that list in. Does that make sense? Okay, so let's look at code. So index utility, the only import you needed here was scanner. We haven't talked about file, but we'll talk about that briefly after this. So you need to import scanner. I called my linked list the list. Okay, so that's a word list. And then this is the main method that people are going to interact with. So this build index. So what does build index do? Well, the list is initially an empty list, so it's a word list, but its header is going to be null. Word is just a temporary. S is the scanner we're going to use to read system in. Word number is telling me the location of the next word in the input. And then the while loop that most people had, while s.hasNext, word equals s.next, call the to lowercase to convert it to lowercase, call cleanup to get rid of things that aren't letters, and then check to see if you've got anything left. If you do, call the add method in the list with the word and the next location, so pre-increment word num. Several people tried to do lowercase conversion by playing with ASCII codes, and I don't think any of them got it right. Because if you're trying to, well, I don't know why, but lower cases would get swept up together with underbar sometimes, and it just kind of, it came out strange. So two lower cases there to do conversion to lowercase, right? Take advantage of it. And subtracting 32 or adding 32 to an ASCII code, that works for ASCII, okay? The world's a lot bigger than ASCII, okay? The A in ASCII is American Standard Code for Information Interchange. Non-Arabic, non-English languages, non-English character sets, ASCII doesn't work. Okay, so there's 16, 24, 32-bit Unicode codings, and you can't do the same trick to convert. Two lowercase knows how to deal with that. So read a word, clean it up, add it to the list. Loop forever. When you're done, close the scanner and return the list. That's the whole build index method.
Where is your cleanup function?
Yeah, we'll get to that in a sec. So, and you could have cleaned it up here right after you say two lowercase, but you know, to me that was a separate set of things. That was a separate subtask. I wanted to write that and test it by itself, so I threw it in a different method. And my goal was to sort of keep this code as simple as possible. So it's a while loop with basically three things happening. And all the gory stuff, taking your word and looking to see if it occurs and inserting in alphabetical order and adding to the end of the linked list and so on and so forth, is all contained in this one set of symbols. Right? That's what you're after with object-oriented design. I don't have to worry about how that's going to happen. I'm just specifying what I want to have happen. And it's just like when you call malloc in C, or you call square root, or you call scanf. you're not worried about how is it going to do this. You're thinking about what do I want to have happen here. I want to take a string and see if there's 2 integers in the beginning and store them in these variables. And you write a piece of code that says this is what I want. So that's what this is right here. I want to add this thing to the object called the list, which is a word list. And then later on that code gets fleshed out. Alright, so the cleanup method, I did this kind of barehanded because I like knowing exactly what's going on. So output string is initially empty, go through the entire string, so I goes from 0 to in.length parentheses. Remember, for a string, length paren is a method that tells you how many characters are in the string. For an array name.length without parentheses is a field.
Does that imply that it's at time n complexity?
It's going to take some time, and yeah, it'll turn out to be n probably, but maybe not. Maybe inside the string there's a field that actually tells you how long it is, and maybe it just returns the value of that field. But the whole loop, yeah, will be order n complexity at least.
I was just talking about, is that why it's parentheses compared to the array that doesn't have the parentheses?
It's parentheses because it's calling code basically. So there's something, if you find the source code for the string class, there's some chunk of code that's going to execute when you call length. So parentheses say you're basically making a function call. Without paren, you're just reading a value from memory. Alright, so go through each character, and if the character at position I is a letter, then I append the character at position I to the output. And when you're done, return the output. So a lot of people use replace all, which is another method inside a string. And if you bundle that with the right kind of regular expression, you can say replace everything that's not a letter. But about half the people who did that ended up including underscores, depending on how you write the regular expression. So, like I say, I like to be explicit. It's easier for me if I sort of like know exactly what's going to happen in here. So that's all the cleanup was. And I think that's the whole index utility class. So word list, that's the linked list of linked lists. So it has a header. I didn't use a sentinel. Some people did. Fine if you want to use a sentinel. It simplifies some of the code. So header was a word list. The constructor for word list just sets header to null. That's how I indicate an empty list. If you have a sentinel node, you set the header equal to an initial node and make that node's next equal to null. So the real workhorse is add, so adding a word at a position. And there's some cases to deal with if you don't have a sentinel. So if the header is null, the list is empty, we simply create a new word list node. And this constructor stores this word with this location associated with it, and just set the header to that and return. And I like to use returns like as soon as I know that I'm done, because it saves me from putting things inside more brackets. If I didn't say return here, I could have said else, curly bracket, and then all of this would have gotten inside one big curly bracket and shifted over a little more. That works fine, and there's some people who get dogmatic about saying you should only return from one spot in your whole program. And if that feels better, you can do that. But I like to keep things simpler when possible, and to me, I don't want to have to read all of this code and think about where the ending bracket is for an else statement, and then go back and see, you know, when we're in the if or the else statement. So I just say return, we're out of there, we're done, right? And that's also why I put this condition first, because it's short, and if the header's null, I don't have to think about it anymore. If the header's not null, I just ignore that top part, and I start looking at my code right here. All right, so I did the previous current trick because you want to keep track of two nodes so you can sandwich in between. So I started off with previous being null as kind of a trick, and current equal to the header. So if I find that I want to insert before current and previous null, I know I'm putting into the beginning of the list. And remember, if you don't have a sentinel, and you want to insert something before the node that's at the head, right? You still have that point to the node that comes after, but you have to actually change header to point to that new first node. Right? With the sentinel, the header is always pointing to the sentinel, so that never changes. But no sentinel, we might have to change header. So loop through until current is null and use the compare to method. Right? And if compare to is bigger than 0, and it may not be 1 or minus 1, it could be anything positive, negative, or 0. So if compare to is positive, then I want to insert before current. Okay, so I make a new node. I could have done that outside. And I point this new node to current. The node is going to come after it, and then here's my check to see if previous is null. That means I'm inserting the beginning of the list, so I just set header to point to the new node. Otherwise, there actually was a node called previous, and I just set previous to point to the new node. And then, either way, you're done. And so again, just take a return right there. Alright, so the first part is list is empty. This while loop is basically looping through, and at this point we just found where to insert our node. Okay, and if we do that, we return and we're done right here. If we get down here and we haven't exited, it means that we haven't found the right place to insert the word yet. So maybe, since the word at current didn't come after our current word, maybe it's equal to our current word. So check to see if current word equals the word that we're inserting. And if it does, here's another one of these magic things. All you got to do is run this. So take the current node's reference header, that's what we call the location list, right? And call its add method and add the number num. And that adjusts the linked list in that node to store that reference. And then again, return. So we're out of there. So now if we get down to here, we're still searching the list. That sounds kind of cool. We're still searching the list. Current node does not match our word. This isn't the right place to insert, so what do you have to do? You have to move down the list. So our usual pair of statements, set previous equal to current, current equal to current next, and then go back to the top of the loop. And if you're in VI, you can hit a % to match brackets, so you can find out where the loop fits like that. All right, if we come out of the while loop, this is our last edge case, we made it all the way through the list, we got to the point where current is equal to null. So this was previous, this was current. We get to the bottom of our loop, we say previous equals current, current equals current next. So this becomes previous. Current becomes current next, which is null. And we know that we're done. Right? It should not have been inserted before previous. It's got to go at the end of the list. So end of the list, we just have previous point to it. So I go ahead and call my constructor, and I just say previous next equals that, and you're done. You inserted. And then the print method, usual linked list traversal. Start off at the header. As long as it's not null, print out the word, and then a colon. And then I put a toString method inside the word node, inside the location list, and just printed that out by concatenating. So the word list node is a word that's a string, a word list node which is next, and then a location list which is the reference header. And there's a constructor that saves the word and creates an empty location list and stores the position where that word occurred. Because anytime we create a new node for this word list, it must be because we just found a word in our input and we know what location we found it at, so we can make those both available to the constructor, and so we can use the reference header and initialize that linked list. So location list, nothing exotic here, straight linked list of integers. Header is a location list node, initialized to null in the constructor. There's an add to end method, which I just called add. So construct a new node. If the header's null, have the header point to that new node and you're done. This should look familiar. But we don't need to store in order because we're always adding to the end. So make a temp that starts off at the header, and as long as it's not pointing to null, go ahead and move down to the next node. When we come out of this, temp is going to be pointing to the last node, right? The node where the next field is equal to null, and just change the next field to point to your new node. ToString method is a straightforward traversal. So if the header is null, just return an empty string. That should never happen because we're only creating these things when we have at least one number to put into the list. But it's good, sort of keeps things general. Otherwise, again, make a temporary header, concatenate the header's data to the output string, and then move down to the next node. And then here I just said if we're not at the end of the list, go ahead, tack on a comma followed by that node's data and move to the next node. And then when you're done, return the string. And then location list, just a standard 2-element class, data, and a pointer to another location list node with a constructor that initializes both fields. And then the main test, which was already posted in the assignment, right? Basically construct an index utility, call the build index to get a word list, call the word list print method to print out the index. So lots of different ways to approach this, but hopefully this idea of sort of breaking things off into different logical pieces and using these objects as sort of standalone things that come with not just data but code for manipulating the data, hopefully that's starting to make more sense. We'll get a lot of that in PA3 because we're necessarily using objects that way when we do things like a J button, right? We're not going to write code for a J button, we're just going to use this class that's already provided for us. But it's a thing, but it's got methods like set label, set text, and so on and so forth. All right, so questions about PA2? I mean, if I put comments on your code about ask me about this or things like that, please follow through on that. All right, PA3 questions. Got any calculators running? Cool. Let's talk a little about algorithms for PA3. And there's your basic view of PA3. Get number 1, get an operation, get number 2, and then display number 1, operation number 2. And then maybe go back up to the top. That's like a really, really crude view of PA3. But it's a starting point. Right? So getting number 1 or getting number 2 get a digit, append to the display, and go back up here. There's a really high-level view of how we get a number from the user. So they push the 3 button, tack the 3 onto the end of the display. They push a 7, tack a 7 onto the end of the display. Now the display says 37. And you keep doing that until they hit a plus or a minus or a times or a divide. And at that point, we need to actually get the number that they've entered. So the display, if it's a text field, for example, or a JLabel, it has a getText method, which will return the text. And if they're doing an integer, there's a method in the integer class called parseInt. And you can say integer.parseInt, that string that's in the display, and it'll give you back an integer. And you just set num1 equal to that. The fact that they've hit a plus or a minus or a times divide is why you did that, right? Why you knew they were done entering num1. And at the same time, save some sort of flag that tells you what operation they hit. So if it's a plus, save a plus in a character, or save a 1 or something. And now you're trying to get the second number, and you're going to do that until typically they hit the equals sign. So same thing, they hit the equals sign, you take the display's value, you get it as a string, you pass it to integer parseInt, you save that as num2. And now you've got an integer called num1, an integer called num2, you've got maybe a character called operation, which is a plus, a minus, a star, or a slash. And now we have to calculate the value of num1, operation num2. And you can do that with a bunch of if statements. You can do it with a switch statement. So you could switch on that operation. You could say case plus, answer equals num1 plus num2. Case dash, answer equals num1 minus num2, and so on. And then you have to display that, so you use the setText method in the JLabel or the text field or whatever you're displaying on. So at a high level, right, it's a few steps. There's details in there, right? There's details if they type in too many digits. When you try to do your parseInt, you're going to blow up. So maybe you want to try doing a parseInt before you add the next digit inside a try-catch block. And if it throws an exception, then don't append that digit to the display. And that tells the user they've typed as many digits as they can. Maybe you want a backspace button, which would just take the last character on the label and just remove it. Right, so you can do that a variety of ways. Maybe if they type number1, operation number2, and they type an operation instead of an equals, you want that to act like an equals, but also like an operation. So you go ahead and you calculate this and you display the result, but you do something to say, okay, now they're trying to modify the current value. But that's the first level view of it. Does that seem doable? Okay, good. I would probably say this is the thing to get going first. All right, just displaying a digit, displaying a number. And the other trick is, remember, this is not a actual loop, right? There's not going to be any while loops in sight, probably. We're not going to loop through and read a character at a time and append it to a string. This is all event driven. So in practice, when the person hits a digit, you set up a listener that starts executing this code, right? And getting the digit is basically just knowing what it was that got you into this section of code. Well, if each digit button triggers a different piece of code, right, inside that code, you can say digit equals 5, digit equals 8, right, and then call your code for appending that to the display. And then when they hit an operation, that's when you basically say, okay, take the current display and translate that to an integer, save that as num1. And since they hit a plus, I'm going to set my operation character to a plus sign. And I'm going to set a flag to say I'm inputting num2. And my advice, as usual, is don't worry about the details up front. Right? Make something so you can hit a button and it appends it on the display. Or make something so you hit a button and it just shows that value on the display. That's a fantastic progress point. Right? Hit a 5, it shows a 5. Hit a 7, it shows a 7. Because that means your listener is working, it means you're identifying the buttons, it means you can access the display's text field, and so on and so forth. And once you can do that, appending the digit to the end of the display instead of just showing that as the entire display is one line of code. Instead of just setting the text equal to 5, you set the text equal to the current text plus a 5. And worry about the special cases later. Worry about division by 0, or they hit an operation key twice, or, you know, whatever. Get something basic working first. It's more fun to add things to a working piece of code than to have 500 lines of code that doesn't compile.
How hard do you think it would be to use the fraction class you made?
I was thinking about suggesting that. I think it's totally doable. But I think to put it on the assignment as an option would take so much description of, right? So if you want to do that, talk to me about it. Tell me what your thoughts are. Because I think it would be really cool to have a calculator that does fractions. So you could say 1/3 plus 2/5 equals, and it would do 1/3 plus 2/5 and show it to you as a fraction. And probably not too hard since you've already got a fraction class. So yeah, I would definitely be open to suggestions on doing that. And we can figure out how many points that's worth. That would be cool. All right, other questions? How many people have Eclipse working? Cool. Okay, that's promising. All right, we got 5 minutes. Let me talk about file I/O. Okay, so we're constructing a scanner to read from input. We can do system.in to read from standard in. We can also use the same scanner to read from a file. So I can say new scanner, new file, and I can read from a file called haha.txt. And this is going to work exactly the same as reading from system.in, except it's going to read from this file called haha.txt. And so file is another class. And we can construct a file a number of ways. One way is by specifying just the name of the file as a string. So you can say file and put in a path name. And we can do a bunch of things with files. We can check its permission bits, we can compare two files to each other, and so on and so forth. But we can also pass the file to a scanner's constructor and create a scanner. And then if we say scanner dot next line, it'll read the next line from the file instead of from standard in. I'm not going to have time to do this. And here you definitely want to close your scanner because you have your file open.
You have to import a file.
And you have to import file, which was java.io.file. But this won't actually compile correctly. Because it knows that it's possible that the result of new file is going to be null if the file cannot be opened, and so the scanner might actually throw an exception. So we have to put this into a try-catch block, which I can't do in 10 seconds. But we'll wrap that up tomorrow, or you can play with it. But then once you do that, basically everything you can do with scanner still works for file I/O. All right, so I'll see you tomorrow.